I think it's around 11:15, so I think we'll get started. Thank you everyone for coming. My name is Mark. I'm an engineer on the Hadoop development team at LinkedIn. I'm going to talk a little bit today about performance in Hadoop and some of the challenges that we had with it, and a tool that we built called Dr. Elephant, which helps users do self-service performance tuning. So before I get into the rest of the presentation, this is a Hadoop Summit talk, and so I would be remiss if I didn't take the opportunity to brag a little bit about scale. So unlike other talks, though, I'm not going to talk about the number of nodes that we have or the number of petabytes. I'm going to talk a different kind of scale, a different kind of complexity, which is the complexity of our user community. At LinkedIn, we have, in addition to fairly large Hadoop clusters, we have a very large Hadoop user community. It's comprised of multiple thousands of users. During any given month, there may be a few hundred of those active. Those users are responsible for thousands of projects, tens of thousands of jobs executing every day. And the interfaces that they actually use to interact with Hadoop, the portals that they go through, are equally as diverse. So we have people who are using raw MapReduce, we have people who are using Pig, Hive, Scalding, Crunch, Hadoop pipes, all these different interfaces. And then we also have a lot of internal sort of vertical stacks that are customized for doing experimentation or metrics calculations or those kinds of things, right? And so the Hadoop user community at LinkedIn, it's a diverse group of people. It ranges everything from engineers who are building data products, things like relevance recommendations, people you may know is an example of that, to sort of analysts doing business reporting. It's really the whole spectrum. And so as the Hadoop team, it's sort of our responsibility to make sure that this entire complex ecosystem sort of works together, right? And these are sort of the four key items that the Hadoop team, my team at LinkedIn, concerns ourselves with. Our core responsibility is that we take the upstream Apache releases, package them, backport any fixes that we need, and make sure that they work for the users at LinkedIn. When something's not available in open source, we build it ourselves. But then, in addition, we have very large investments in both hardware, but also in people. And so we want to make sure that our hardware is being used efficiently, and that the people who use our system are spending their time efficiently, right? And so what are the ways that we can do that? So this is unrelated to the rest of the talk, but I have a captive audience, so I want to take the chance to pitch a couple of projects that we might not otherwise get a chance to talk about. So one of the tools that we built that sort of helps people spend their time more efficiently on Hadoop is called ByteRay. ByteRay is a compatibility tool. One of the challenges that we've had is as people migrate from Hadoop 1 to Hadoop 2, there's a lot of inconsistencies, there's a lot of incompatibilities, and if you aren't familiar with the system, it's very difficult to sort of navigate and to port existing work, maybe work that you never developed in the first place, to the new system. So ByteRay is the tool that we've built, which will look at your deployable artifacts, whether they're jobs or jars or zip files or what have you, and check to see whether these are artifacts that make sense to run on Hadoop 2, right? So that's one thing we built. Another tool that we have is the Gradle DSL for Hadoop. I think every sort of sizable Hadoop deployment has some workflow manager, whether it's Uzi or Azkaban or Luigi, or I think Airbnb recently announced their new one. Everyone has their own workflow manager, but there's no real standard way of how do you actually manage your code base? How do you have all your dependencies? If I have a workflow that needs to have some parts in Pig, some parts in Java, some parts in Scala or Spark, how do I bring that all together and have related components live in the same code base and function together? So The Gradle DSL is a plugin for the Gradle build language. For those of you who aren't familiar with Gradle, Gradle is a tool which it's very similar to Ant or Make or Maven, just sort of a newer build language. So we have a tool that allows people to explicitly define their workflows using that build system. But what about tuning? So, I mentioned before that two of the key items that my team is concerned with is optimizing our investment in our hardware, our resources, our data centers, and also optimizing our human capital, so to speak. Usually, we err on the side of making things easier for people and harder for machines because at the end of the day, it's much easier to buy 100 or 1,000 new machines than it is to find 20 really solid developers, right? And especially, I think, certainly what we've seen at LinkedIn, and I think this is common at a lot of Hadoop places, is that when you're first starting, the solution to a lot of problems is just sort of, if we can solve it with more hardware, let's do that, right? Because we know it works, we don't have to worry about it, right? But that only goes so far. Eventually you run into scalability limits, or you just blow out your budget and you have nothing left over, right? So you can't take that, you can't keep that going forever. In addition, a lot of jobs, even to just get them running, you're going to have to spend some time tuning them. You're going to have to tweak around with memory parameters. You're going to have to play around with shuffle parameters or join algorithms or any of these, right? So you're going to have to spend some time learning the system anyways. And if you only put in the minimum amount of effort, you're sort of stuck in the worst of both worlds, where you both are wasting a bunch of developer time on learning the infrastructure, and you're also not really using your hardware to its maximum abilities, right? So why is tuning so hard for Hadoop? I think there's a couple of issues that I've seen. So to give you some background, I've been at LinkedIn for 3 years, and for a lot of that time, a large fraction of my time is spent with users, helping them to tune their jobs. And what I've seen is that the number one problem is that you can't even tell if you have a problem. You can't tell if the performance you're getting out of a Hadoop workflow, a MapReduce job, what have you, is expected, or because there's some lingering problem, right? For a lot of people, their only interface to Hadoop is a Hive command line, or even something even higher level. If you have sort of a BI tool or something like that, you may never know how things are getting executed, right? So the first challenge is that you'll probably never even know you have issues unless you spend a lot of time going and investigating issues, or not just investigating, but looking for issues, looking for problems. And if you try to go look for problems, you're a good citizen. You want to make sure that you're using your resources efficiently. The next problem that you run into is that the information you actually need to decide whether you should be concerned about something is scattered all over the place, right? You have logs on the client side, which will tell you some information. You have the resource manager information, which will tell you maybe some higher level or global view of the world. You have counters for every task, which may be different for each task, but you often need to click through each of these. And then finally, you have, in every task, you're going to have logs associated with that task, which will give you even more information on how was your job actually executing, and what was it doing, and was it spending its time wisely, right? And of course, none of this is, it's not particularly hard to gather this information, but it's not easy either, right? It's clicking across, maybe 100 or so different UIs, and if you're doing this for one job and that's all you're ever going to do, maybe that's okay, but if you're going to do this for a whole workflow and you're going to do it repeatedly, that's a lot harder to do, right? So it's hard to tell if there's a problem. If you really want to look for a problem, it's really hard to find a problem. And then even if you found a problem, it's impossible. Well, it's not impossible, but it's tedious and it's miserable to decide, okay, what do I do about this? So I'll give the example of what I think is probably one of the easiest, or not the easiest, but the most simple things that you might want to change about a Hadoop workflow. What is my map side parallelism, right? This should be an incredibly easy thing to do, but depending on, again, sort of the complexity of your user community, there can be a million different ways to handle it. So I was writing these slides and I got tired of sort of going down the rabbit hole, but whether you're using Pig, you have to set some settings. If you're using Hive, you need to do something else. If you're using Java, you have to extend the combined file input format, and then you have to worry about the size of your blocks, and you have to worry about the min and max split size. And for a newbie or a new user on the system, this is just sort of overwhelming. And if you're trying to, I had difficulty just remembering all this. For a new user trying to learn it, it's a monumental task, right? And this is just one parameter, right? This is just how do I change the number of mappers, right? The problem is there's a million more parameters, right? It's not just the number of mappers. It's all of these things. And every additional layer that you have in your stack, first you start with HDFS, and then you pile MapReduce or Tez or Spark on top of that, and then you pile Pig and Hive on top of that, and you just keep piling layers on. And each new layer is going to add more and more complexity to the system, right? So I looked at the configuration parameters that are available in MapReduce and Hive. MapReduce alone has 200 configurations you set. Hive has 300, and these are added at a rate of something like 60 new parameters every year. So it's not a trend that's slowing, right? So the tuning Hadoop jobs, it's sort of like a black art. There's no real clear indication what you're supposed to do. There's a million settings that you can do. At the end of the day, it's not, the experience is not sort of this. You don't need to just sort of sit down and twiddle a few knobs. It's more like this. It's a space shuttle. It's incredibly complex, and if you don't have a lot of experience with the system, it's a miserable experience, right? So this is a terrible situation. What can we do about it? First, what can we not do about it? I'm going to go over a couple things that I know don't work, and I'll advise you guys against them. We did these at LinkedIn, and it was a disaster, or not a disaster, but it was miserable. One strategy is you hire some experts and you tell them, tune our stuff, right? But if you have, certainly at LinkedIn, we're sort of in the situation I mentioned, a couple thousand users, tens of people who really are sort of qualified to know everything that the system is doing. And there's no way that you can sort of get good coverage over the entire, all of our workload with that number of people, right? And so if you can't cover everything, what should you look at? What jobs should you investigate? Should you investigate the largest jobs or the most business critical jobs? Even if you can get a person to sit down and spend all day looking at jobs and tuning them and just sort of having their eyes glaze over and doing this all day, they're not going to be very accurate. At some point, you just sort of let things slide. You say, this could be improved, but I'm not going to really care about it because it's too much effort, right? And finally, if you have users relying on experts for guidance, that's going to introduce additional delays in development, right? They have to go over talk to someone, even if they're in a different office. They are going to email, and it's a bad situation, right? So expert intervention for tuning does not work. The other thing that doesn't work is you can't train everyone to tune. The fact of the matter is most people who come to Hadoop shouldn't care how the infrastructure works, right? For most people, knowing the internals of a distributed processing system does not make their day-to-day job. They're not more productive. They're not more efficient. They're not creating more value for your organization, right? So if you try to tune or train everybody, you waste everybody's time training them. The actual material that you need to teach them about is always changing. You can teach them everything for pig, but then the next day they're going to need to use Hive and they'll have to learn a whole new set of parameters, right? And what it really boils down to is that users really shouldn't, they don't care and they shouldn't have to care about tuning, right? It's not their responsibility, it's not their job, it's not the, it doesn't, it's not what they're responsible for, right? Which brings us to Dr. Elephant. Dr. Elephant is sort of LinkedIn's response to some of these problems that we saw. The number one goal when we were developing Dr. Elephant was that we wanted to help every user to get the best performance out of their jobs, right? And so that means, it needs to be resource efficient, it needs to be high throughput. We want to help people get the sort of the lowest latencies for their job so they can run it more frequently and get more value out of it, right? But we need to do that while not, we can't impose all this burden just directly on the user. We can't just tell them, here's a stack of information, you go handle it. Let us know if you have any questions, right? Because that won't work. They'll never sort of buy into that situation, right? And so we can't have them, or at least we feel that it's not appropriate to have them be responsible for learning the whole infrastructure just so that they could get good performance. And it's not their responsibility to take the information that we're giving them and have to sort of experiment or do a lot of development with it. And then finally, as sort of a side note, performance is a pretty important topic when you're talking about multiple thousand nodes clusters. So we wanted to build sort of a source of truth that would give us the ability to build more tools later on, and I'll talk about those later. This is Dr. Elephant itself, the main page when you sort of go to the Dr. Elephant service. This page is not, it's pretty, it's not too useful on its own, but it gives you a sense of how is the cluster doing as a whole, and what are the jobs that have finished recently, and what is sort of the Dr. Elephant's opinion of them. What's really interesting, though, is the search. And so the search allows users to dial into what are the jobs that I have run on a cluster in the last however long you've deployed Dr. Elephant. We don't have a retention on our instance. And for each of those jobs, Dr. Elephant will sort of give you a report on different features that it knows about. So we, based on the Hadoop team's experience, building, maintaining, and tuning Hadoop jobs. We have built these sort of rule-based heuristics that say if these parameters are out of sync or the ratios of these two values are not right, then someone needs to take a look at this and change it, right? And so let me show you an individual job. Also, you get information about what was the actual identity of this job. Although from like an infrastructure side, we tend to think of things in jobs. From a user's perspective, you're typically thinking of workflows or pig scripts or that kind of thing, right? Your unit of development is at a higher level. So one of the nice things about Dr. Elephant is that it gives you the ability for each job to look back at what's sort of the identity of this job, so to speak. What job was it a part of? What job execution? So you can see logs related to this job. What flow execution? So if this is a daily reporting workflow, you can have a link that will show you it's this report specifically, and it's this line, and this is what this job is doing. And then here are the things that we've identified as needing attention for this job. But I mentioned, so this sort of, this solves the problem of how do we find performance problems, right? Dr. Elephant is always watching, it's always monitoring all jobs, and so it'll collect this information and give it to users and tell them, hey, this is something you can look at, but it doesn't really, at this point, it doesn't really give you any insight into how do I actually resolve this, right? How can I fix this situation? And that's what we built sort of the help pages for. So let me back up a second. So you'll notice I don't actually have any flagged issues on this slide, but each sort of rule, it has the ability to provide an explanation for why it got sort of the health status that it did. So this one is considered healthy because you don't have too much skew among your mappers, right? If it is flagged as an issue, then for each of these issues, we also have a help page that allows people to get an explanation of when does this issue get flagged, what are the immediate changes that you can make to improve it, and if the user really wants to sort of learn more about the system, we also have an explanation that gives them an idea about how the internals of the system affect this problem, right? So that's sort of Dr. Elephant from a user's perspective. Internally, like I mentioned, Dr. Elephant is a persistent piece of our infrastructure. It watches the resource manager or the history server or the timeline server and identifies any new jobs that have finished. For each of those jobs, it will do, I was talking before that there's information scattered all over the place. Dr. Elephant does that for you. It collects all the information and then just passes it to these sort of expert-defined rules that give an evaluation on the health of the job. And all of the information that I just showed you through the UI is also available through a REST API, which means we can build tools on that. And so that's what I'll talk about now. I mentioned the process for tuning a job. It's sort of, discover a problem, or look for a problem, discover a problem, fix a problem, right? And you can do this once, and that works. And even if you have a beautifully tuned workflow and everything is just humming along perfectly, if you leave that workflow and you run it every day and you go develop something else, if you come back to it in a month, it's going to look very different, right? The size of your data set will have changed. The distribution of your data will have changed. Maybe some values that were used to be very small or very low frequency are now very high frequency. Even if you haven't changed your job or your data is the same, behind the scenes hardware may have changed. And often what we see is, at LinkedIn, usually there's not one person developing on a Hadoop workflow at a time. There may be multiple people responsible for that workflow. And small changes build up over time, right? It doesn't even have to be a re-architecting of the workflow, but if you change sort of one transformation to include or exclude some parent or some records, and just sort of make small changes over time, the performance of your workflow will sort of drift, right? And so what used to be good is now bad. So we have built a tool on top of Dr. Elephant. It doesn't have a catchy name, unfortunately, but it will look at over the last day, what are the jobs that have run? Do we recognize these jobs as being scheduled workflows? Are they part of a registered project? Something that is either every day collecting statistics or calculating metrics or pushing data to the site or that kind of thing, right? And because because Dr. Elephant knows that a job is part of a workflow and that a workflow is part of a project and that kind of thing, it can actually look back at previous executions of that job and see, has the performance changed? Has it degraded? Has it improved? And once you know that, when you see sort of there's a cliff in your performance when something's gotten much worse, you can actually compare that back to what changes have been made to that job recently that caused that, right? So we run this on our production clusters, and it gives us insight into, what has anybody done anything recently that has significantly degraded their performance, right? And if all of a sudden we see, for example, that performance or the health of jobs has really degraded, but people aren't changing their workflows, then it's usually a sign that maybe there's something wrong with our infrastructure, if we've deployed a new version of Hadoop, that kind of thing. It gives us more insight into the health of the user community as a whole. The other thing we do, so I mentioned that we have a sort of specialized production cluster that is reserved for what are considered to be business critical workloads, right? We want to separate those out as much as possible from the development or the ad hoc work where things are less certain or more unstable. But to sort of maintain the cleanliness or the sanity of that system, we'll actually audit workflows before they are deployed there. So this is something that we used to do a bit manually, and it was very difficult. But now with Dr. Elephant, using Dr. Elephant's REST API and using some integration with Jira, we can actually automate this entire system and have users go through an audit of their workflow without us being involved in the process. And so I think, and so this has given us, it's improved accuracy because Dr. Elephant will actually look at every single job that you run rather than just like skipping half of them, which people usually do. It's faster turnaround, it's almost instantaneous, and Dr. Elephant never gets tired. It can run at 3 a.m. in the morning. If the users are up, Dr. Elephant is up, right? And this also led to what I think is my favorite moment since I've joined LinkedIn, when one of our users, after we had first deployed this, believed that Dr. Elephant was, I suppose, a new hire on our team with a funny name, and began conversing with the tool itself. So I've talked a lot about sort of what are the benefits of Dr. Elephant for users, right? It can help them understand why their jobs may be running slowly. It can give them ideas for how do they want to fix their jobs. But it's actually also incredibly useful for operators, right? There's a lot of tools that give operators of Hadoop sort of a global view of the cluster. Even Hadoop has built-in metrics facilities that will tell you what is the overall utilization or that kind of thing. But there are very few tools that will actually tell you these are the particular jobs that are having an impact on the efficiency of your cluster, right? And so very soon after we deployed Dr. Elephant to our clusters, the first thing that happened was our operations team would go see what are the top listed jobs, what are the ones that are absolutely the worst of the worst. They're huge jobs that are spending they're spending all of their time in just overhead and aren't doing anything really useful. And then we can call out those users and say, hey, you need to stop running this, come talk to us, we have to fix this situation, right? The other sort of operational consideration that Dr. Elephant plays into is that now at LinkedIn, Dr. Elephant is sort of considered the source of truth for whether a person or a project or a workflow is using their resources that are being given to them efficiently, right? And so if people want more resources, either they're going to build new features into their product, or they expect data growth, or whatever their reason is for needing more capacity, since we've deployed Dr. Elephant, sort of the first question that gets asked, often even before they'll come and talk to the infrastructure team, is, does Dr. Elephant say this is all green? Does Dr. Elephant say that you are using your resources efficiently? And if you're not using your resources efficiently, then we're not going to support your need for more capacity. You need to just suck it up and tune things. And Dr. Elephant will help you. So we've had Dr. Elephant, we've actually had it internally for a little while now, about a year actually. One of the things actually that's really cool about Dr. Elephant is because it tracks the health of the cluster, and its goal is to improve the health of the cluster, or I should say the health of the user workload on the cluster, we can actually see over time how things are doing, right? And so the graph on the left there is over a period of about a year. What fraction of jobs does Dr. Elephant identify as being perfect, as having no issues that need even a little bit of attention, that everything is good about them? And so you can see that over a year or so, we've gone from about half of our jobs being absolutely perfect to 75 or 80% hovering around there. And Dr. Elephant doesn't just have healthy or bad. It also has sort of a range in between. And so more jobs are healthy and fewer jobs are the worst of the worst is sort of what we see. The other thing, I mentioned a little bit before that there's sort of this emergent behavior where now when people, before they even ask for resources, they'll first check with Dr. Elephant to make sure they're covered and nobody can accuse them of doing anything wrong. The other great thing is that because Dr. Elephant gives a view on all jobs, you don't have to go and ask it about your job specifically. You can see what all your colleagues are doing. You can see if someone else is using all your resources. You can see in the yarn scheduler that someone is hogging the cluster for hours on end. It's very easy to find out, are they actually doing anything useful with that time, right? Or are they just burning cycles? And if they are just burning cycles, Dr. Elephant sort of gives you the evidence and the data that you need to confront them or assault them or whatever. And then the other thing I'll mention that we found over time is just sort of to reiterate the point that tuning is not a fire and forget thing, right? You don't do it once and then leave it forever. You do it once and then you need to sort of keep monitoring it, right? And without a automated process always sort of checking in on the health of your job, that's very difficult to do. When we first deployed Dr. Elephant, we somewhat expected that there would be a lot of jobs that hadn't received a lot of tuning or performance attention. What we weren't expecting is that a lot of the jobs that we had considered to be developed by the experts of Hadoop, developed by people that we assumed were spending a lot of time tuning their jobs, who were using the resources ultra efficiently, those jobs turned out to be some of the worst because they had been developed 5 or 6 years ago and no one had really revisited the question of, are these written the right way? So I've been talking a lot about MapReduce. Dr. Elephant itself is not necessarily tied to MapReduce. MapReduce is the framework of choice that we implemented first, but the architecture of it allows us to extend it to anything. So we have plans to extend it to Tez and Spark. The nice thing, though, is that the plugins are structured in a way so that we, as sort of the developers of Dr. Elephant, do not have to be the ones who are defining what the best practices are, that have to know the rules to define for each framework. We can allow other teams to say, hey, I have this new tool that I'm going to let people use. I want to add something into Dr. Elephant so that it can understand the performance of my tool's jobs, right? And so Spark, for example, is actually being predominantly developed by another team at LinkedIn, and we've only sort of pointed them at the code base and told them how Dr. Elephant is sort of laid out. So I said at the beginning I wasn't going to brag about numbers, but now I'm going to brag about numbers. So right now, Dr. Elephant's deployed across around 8 or so different clusters, summing up to 10,000 or so nodes, and every day it's processing 60,000 jobs a day and serving those to users. And so so far we haven't had any real issues with performance. Like I said, we retain data going back forever. And it's been working great so far. And we have an open source, or we're planning to have an open source release pretty soon. And with that, I'd be happy to take any questions. I think there are mics on the side.
What kind of criteria do you use for weighting your?
Sure. So the question was, what criteria do we use? So I mentioned that it's all rule-based, right? So these are things that we had defined. They were sort of best practices that were understood within LinkedIn and the team before. It's things like, what's your ratio of shuffle time to actual compilation time? What's your reducer skew? What is your ratio of input data size to runtime, right? Are you taking 10 hours to run on 10 kilobytes of data, right? We've seen some cases where someone had written a pig UDF that every time it processed a record, it opened a new file on HDFS, right? And so they're processing 3 million records, and that takes like 5 hours, even though they're doing very little work. The rules are actually This is a little bit internal, but the rules are defined in a way, and you can actually turn them on or off without actually changing Dr. Elephant itself. So if you have a Dr. Elephant release, it's as sort of a third party when we open source it. The idea is that you will be able to, if there's something that you particularly want to be signaling on, you can add that as a rule and just say, Dr. Elephant, I also have this other one. Please, take that into consideration.
Are you planning on open sourcing any of this, and what language is it written in?
So it's all written in Java. Yeah, it's all written in Java. It's used is the if you're familiar with the Play framework, it uses that. The plan is, yes, we're planning to open source it. Probably Q3 is when we're going to focus on sort of cleaning it up and going through the process.
How easy is it to extend to pick source code recommendations, like turning on map site aggregation features or something like that?
Right. So the sort of general structure of it is that, and I'll just talk about like one framework, for example, but it's the same for all of them. You write you first write the rule. So if you have some feature that signals that a change is warranted. So for map site aggregation, for example, I guess the ratio of map output records to reduce output records is usually a good indicator that that's something worthwhile doing. Dr. Elephant also, in addition to collecting sort of tracing or performance information, it collects the job configuration. So with Pig or Hive or those kinds of things, you can actually see what were the parameters that were being set, and is there actually an opportunity to improve that?
Thanks.
Sorry, I'm going to go over here.
Hi. Do you have an architecture slide or a block diagram that shows the design, like answer simple questions like what's the backing store for persistence and that sort of thing?
So I didn't do it because honestly, the sort of surprising thing about this is that it's been really successful and it's not complicated. There is a single service which watches I mentioned either the job history server or the resource manager. It uses a thread pool to collect all the information, process it, and then store that in a MySQL database. It's really nothing fancy. Yes.
I have two questions. One is simple. How do you specify the rules? Is there like a language text?
It's a XML configuration similar to how you would define how would you configure the capacity scheduler. It's similar to that.
Also, the second question is, how do you handle if there is a conflict in the role? So do you give priority to the roles?
So one of the things that we do is even if one rule decides that there is a problem and it flags the job, we'll still look at all the other rules to see what else there is. So I'm not sure I understand what you mean by conflict, but if there's sort of, we essentially give the results of the rules directly to the user and give guidance on like when this rule fails, you'll want to go and make this change. I guess. Mm-hmm.
Optimize time. So something like that. Like, how do you give priority to rules or?
So usually we look at sort of lower level features rather than trying to have there are other tools which do sort of performance analysis, which have you start with the high level goal of I want to optimize something, and then you just try all the parameters and you do gradient descent and you discover like what is the shortest time, right? Dr. Elephant is sort of the reverse. You start with rules, you start with the ability to identify for a given job, does it have sort of this unique pathology? Does it have bad, I mentioned before, bad shuffle to sort time ratio, right? And then from there, you need to have sort of the starting expert knowledge to say that this is indicative of this problem, and you should go and change this. So the rules are at a much more granular level than I want to optimize time or I want to optimize memory. For Spark, I'll mention that sort of memory is an example. So for Spark, we will do things like look at how are you allocating the amount of memory that you reserve for caching RDDs, how much of that memory are you actually going to use, that kind of thing.
Question on upgrades. You said Dr. Elephant was more purposely driven for upgrades. What were the things that got identified by Dr. Elephant when a new HTTP 2.2 got released? If you could share some with us.
The main thing was that sort of the whole system as a whole will just sort of slow down a little bit. And you can see that for the ratio of how much data is this same task processing. Last week it finished in, 3 minutes. Now it's taking 10 minutes, right? It's something that, like, if you're not watching it closely, you might miss, but that's sort of the type of problem. I'm not sure.
So you mentioned that right now it only looks at completed jobs. So if someone kicks off a resource hog, an ad hoc job, and it's running for a while, clearly there's value if you could detect it. Are you interested in providing that? Is it too much complexity?
No, I think the original motivation was focused on like production jobs. So it's not really it's not a fundamental limitation, I would say, but the focus is on sort of the jobs that are running all the time that it's not expected that they'll fail. Ad hoc sort of changes that situation.
Bonus question. How often or how quickly are you adding rules, like as you are maintaining the system?
Not that quickly. We added 6 or 7 or so rules at the beginning. We've tweaked those rules a little bit, but for the most part, we don't add new rules. They seem to just sort of work. Hi, Alan.
Hi. Good stuff. One quick question. So, for example, for shuffle metrics, how much does this take into consideration the heuristics of other things running on the cluster?
Not at all. So the data that we sort of look at is mostly independent. So for what you're getting is like how network affects sort of the performance. So sort of the challenge with that is that the data collection for those kinds of analyses is much more involved, right? You have to look at sort of switch traffic and that kind of thing, right? We sort of rely on the averaging that out over multiple executions, and it seems to work all right. I think I'm out of time. If you'd like to talk to me, I'll be over by that door afterwards. Thanks, everyone.